Today we are talking about subtracting rational numbers. Remember, if I am ever going too quickly, just pause and rewind, and if you have any questions, raise your hand and ask your teacher. So the key to solving any subtraction problem is to first rewrite it as addition. We practiced solving addition problems with negatives earlier this week. We are already pretty familiar with it, so the best thing we're going to do is to rewrite our subtraction problems as addition, and here's how we do it. We are first going to keep our first number the exact same. We're not going to change anything about it, including the sign. The next thing we are going to is we are going to change our subtraction sign to an addition sign. And the third and final step is we are going to turn our second number into the opposite. You can remember those steps as keep, change, opposite, or KCO. It's very similar to keep, change, flip, which we use with division. So hopefully it will be easy to remember. So the first thing we're going to practice here is just rewriting them as addition using our keep, change, opposite steps. The first example is negative 12 minus 10. We are going to keep the negative 12 exactly how it is. We are going to change our subtraction sign to an addition sign. And we are going to make that 10 the opposite. Since it is currently a positive 10, the opposite of that is a negative 10. Our new math problem to solve is negative 12 plus negative 10, which you are familiar with and can do based on the practice we did earlier this week. Next one, we have 13.5 minus 17.64. We are to rewrite this as addition using keep, change, opposite. We are going to keep 13.5. We are going to change the subtraction sign to an addition sign. And we're going to make that last number the opposite. It is a positive 17.64. So we are going to turn it into a negative 17.64. Sometimes kids struggle with knowing the sign of that last number, especially when there's not parentheses around it. So what you can do is just kind of cross off as you go. So I'm going to go back to the first example. We kept negative 12, so I crossed it out. We changed our subtraction sign, I crossed it out. It's very obvious now that that 10 is a positive, which is why we made it a negative when we turned it into the opposite. Same thing with example 2, cross out as you go. We kept our 13.5, cross it out. We changed our subtraction sign, cross it out. It's very obvious now that that was a positive 17.64, so we turned it into a negative when we made it the opposite. Moving on to the last two examples, they're a little more obvious, the signs. We are still going to keep our first number, so I'm keeping negative 4.5. We are going to change our subtraction sign to an addition sign. And with those parentheses around it, it's a little easier to tell that that is a negative 3 1/3, so we're going to make that the opposite, which is a positive 3 1/3. For the final problem, we have 77 minus negative 43. Again, same 3 steps every time. We are going to keep, change, and opposite. Once we have these problems rewritten as addition, we can continue solving like we learned earlier this week. And that's what we're going to talk about next. When you are given a subtraction problem, the very, very first step is rewrite it as addition using keep, change, opposite. That's what we just practiced several times. You need to do this first. It is not a choice. If you do not consistently do this, you will not consistently get the right answer. So you have to rewrite it as addition. So many kids try and skip that step and then they get the wrong answer half the time or even more than that. When you are given subtraction, you have to rewrite it as addition with keep, change, opposite. Once you've done that, we're continue solving just like any normal addition problem. We're going to look at our signs. If they are the same, we are going to add our numbers. And if they are different, we are going to subtract our numbers. The last thing we're going to do is check the sign of our answer. We're always going to give the sign of whatever has more. So the number with the larger absolute value. We're going to practice this a couple times on the front. We've got 4 examples here. I've got my first problem is negative 135 minus 75. Whenever you hear yourself, either in your head or out loud, say the word minus, the first thing you should be thinking is I need to rewrite that as addition. So we are going to keep this negative 135. We're going to change that subtraction to addition. And we're going to make that 75 the opposite, which is a negative 75. Again, another trick is to cross off as you go. We kept negative 135. We changed the subtraction. Now it's very obvious that that 75 was a positive. We changed it to a negative. Now you can look at your signs. You can see your signs are the same. When your signs are the same, you add them. So my next step would literally be to add those 135 plus 75. When you add straight down, you're going to get 210. If I stopped there, I would have about a 50% chance of getting it wrong. And the reason for that is I have not checked the sign of my answer yet. Go back to your addition problem. Look at what you have more of. In this scenario, I am looking at my 135 because that's the number with the larger absolute value. It's a negative, so I have more negatives, and therefore my answer will be negative at the end. Going to the right, I have 1.65 minus negative 3.91. Whenever you say minus, either say it out loud or say it in your head, you're going to rewrite with keep, change, and opposite. I'm going to keep 1.65, change subtraction to addition. The opposite of a negative 3.91 is a positive 3.91. Then look at your signs. Your signs are the same. Since they are the same, you are going to add. With decimals, we need to line up our decimals. So that's exactly what I'm going to do. When you add straight down, you are going to get 5.56. Again, if I stopped there, there's a 50% chance I'm wrong because I need to go back to my addition problem to figure out my sign. Both my numbers are positive. My bigger number, 3.91, is positive. Therefore, my answer is going to be positive. Two left. I have 8 1/5 minus 12 3/8. And whenever I say minus, you rewrite it. So I'm going to keep this 8 1/5. I'm going to cross off as I go. I'm going to change that subtraction to addition. And I'm going to make that last number the opposite. Since I've crossed off as I've gone, it's very obvious that that's a positive 12 3/8. So to be the opposite, it would be a negative 12 3/8. Look at your signs. What you should notice is you have a positive and a negative number. Therefore, your signs are different. When you have different signs, find the difference, which literally means to subtract. Difference is the answer to a subtraction problem. Because we are dealing with fractions, I do also need to find a common denominator. A good common denominator for 5 and 8 would be 40. So the next thing I'm going to do is just rewrite this with my common denominator. To turn a 5 into a 40, I would multiply by 8. And 1 times 8 on the top is 8. And my second mixed number, to turn an 8 into a 40, I would multiply by 5. 3 times 5 on the top is 15. As we mentioned a moment ago, your signs are different, so you are going to subtract. Whenever I subtract fractions, I always write them vertically, just like we do with subtracting whole numbers. When you write it vertically, it's easier to borrow if you need to. I'm going to subtract my numerators. Luckily, I can do 15 minus 8, and I get 7. My denominator stays the same. 12 minus 8 is 4. If I were to stop there, there's a 50% chance I'm wrong because I need to look back at what I have more of. So I'm looking at my addition problem. I have 8 and some extra for my positives. I have 12 and some extra for my negatives. 12 and 15/40 is the number with the bigger absolute value, and since it's negative, that means I have more negatives, and my final answer will be negative. Last one. Negative 7.5 minus negative 6 5/6. I said minus, so I need to keep negative 7.5. I need to change that to an addition problem. And I am making my final number, which was a negative, into the opposite. So it's now a positive 6 5/6. If you look at your signs, you have a negative and a positive. Therefore, our signs are different, and I need to subtract them. Because I'm dealing with fractions, I need a common denominator first. A good one for 2 and 6 is 6. So I'm going to change this negative 7.5 to become negative 7 3/6. My second fraction, since it already has 6 in the denominator, I do not need to change it. It stays the exact same. As I mentioned just a moment ago, our signs are different. I've got one negative and one positive. When my signs are different, I find the difference, or I subtract. So I'm going to do the number with the bigger absolute value on top minus the number with the smaller absolute value on bottom. Unfortunately, this time, when I go to subtract my numerators, I cannot do 3 minus 5, so I'm going to have to borrow. I always borrow from my whole number, so the 7 becomes a 6. I always look at my denominator to tell me how many I'm borrowing. So since I am borrowing or giving 6 this time, I'm going to give that 3 6 more, which makes it a 9. I can now continue subtracting. 9 minus 5 is 4. My denominator stays the same. And 6 minus 6 is nothing. That 4 over 6, they are both even numbers, so I can also simplify that by dividing by 2. That's going to leave me with 2/3. The final thing I need to do is check my sign. So I look back at this addition problem. You always ask yourself, what do you have more of? 7 is bigger than 6 in my whole number, so I have more negatives. Therefore, my final answer is a -2/3. Flipping to the back, we just have a couple more things to go over. It shouldn't take long. We are going to practice one word problem and then a little bit with drawing and number lines. So this word problem, it says Jim has $45.75 in his checking account. Jim then writes a check for $67.98 to pay for a recent shopping trip to get new clothes. Part A wants us to find the rational number that represents Jim's current bank account balance. So the first thing I'm going to do is write an equation or an expression to represent this. If he has $45.75, that means it's a positive value. He has it. So I'm going to go ahead and write positive 45.75. Then he is writing this check for $67.98 to pay for shopping. If he's paying it, that means it's leaving his account, or I am subtracting that $67.98. So my problem that I'm solving is 45.75 minus $67.98. Whenever I say minus, I need to change opposite. I need to rewrite it. So I'm going to keep this 45.75. I am going to change my subtraction to addition. And then I'm going to make that last number the opposite. Since I've crossed off as I've gone, it's pretty easy to tell that that was a positive 67.98. So to make it the opposite, it's going to be a negative 67.98. Look at your signs. You should be able to tell that you have one positive and one negative. Therefore, they are different and you need to subtract. Always do the bigger number on top. Line up your decimals. When you subtract straight down, you would get 22.23. And if I stop there, there's a 50% chance I'm wrong. I need to look back at this addition problem. What do you have more of? Do you have more positives or do you have more negatives? The bigger number in this problem is a negative number. Therefore, my leftover is negative $22.23. Now the question, part B there, is what does this number mean and should Jim have gone shopping? When you have a negative amount of money, that means you are in debt. So that's the first thing I'm going to say. It means he is in debt. To be in debt means that you owe money. You did not have enough. You spent more than what you actually owned or what you had in your account. And because that is the case, we're going to say he should not have gone shopping. He did not have enough money to do that. So he should not have gone shopping. And the reason he should not have shopped is because he didn't have enough money in his account. Again, when you see a negative amount of money, that usually refers to something bad. You don't want negative money, you want positive money. When you see negative money represented, that means you owe someone. You borrowed too much, you spent too much, you are in debt. Moving on to the last two parts there. Some general tips when we use number lines and pictures. I want to go over this with you. So really, using number lines and pictures only makes sense when you're dealing with small numbers. So we're going to practice this anyways. Just like on the front and all those practice problems we did, we have to first rewrite it as addition. So we are going to keep, change, opposite. Again, rewriting it is not a choice. Then you are going to use different symbols for representing positives and negatives in the picture. And on the number line, when you add a positive, you go to the right. When you add a negative, you go to the left. So drawing a picture, we have 4 minus 5. If I say minus, I need to rewrite with keep my 4, cross it off as I go. Change to addition, cross it off. Now it's obvious that that was a positive 5, so it's now going to be a negative 5. I'm going to use just plus and minus signs for these. So since I have a positive 4, I'm going to do 4 plus signs. Since I have a negative 5, I'm going to do 5 negative or minus signs. And since my signs are different, I'm going to cross off one of each until I only have one symbol left over. So I'm going to cross off a positive and a negative, a positive and a negative, positive and a negative, positive and a negative. This is my leftover. I have one symbol remaining, and it happens to represent a negative number, so my answer is negative 1. Moving on to the number line, I have negative 2 minus negative 4. Again, I said minus. I need to keep the negative 2, change to addition, and make that last number the opposite, so it's going to become a positive 4. Remember, you do not always need 0 on your number line, and 0 certainly does not need to be in the middle of the number line. Usually what I like to do is try and figure out what direction I'm going to go. I am adding this positive 4. When you add a positive, that means you are going to the right. Since I'm moving to the right, I'm going to start all the way to the left so I can make sure I have enough room. And I'm always going to start with my first number. My first number was a negative 2 in the problem. Now I'm just going to go up in numerical order. My next line would be a negative 1, then 0, positive 1, 2, 3, 4, 5, 6, 7, and 8 until I'm out of spaces. I am going to start at negative 2 since that's my starting point. That's my first number. I know that I am going right because I'm adding a positive number. Specifically, I'm going to go right 4 spaces. So I'm going to go 1, 2, 3, 4. That is my ending value. That is my answer. And I land exactly on a positive 2. That is my number. That is my answer. All right, so remember the keys with subtracting rational numbers is to first rewrite it as addition. It is never a choice. You have to do it if you want to consistently get the right answer. Use keep, change, opposite to do that. After that, all your rules are the same as earlier this week. Go ahead and check your notes in with your teacher and ask for help if you need it.